beginning our study of Chapter 2, Section 10, so that's Section 2.10 or 2.10. As always, we start by identifying the learning target. The learning target for today is to express numbers in scientific notation. Got to cover a couple rules before we can do that. One is the definition of scientific notation. Scientific notation is a way to express a number as a product of a number that is at least 1 and less than 10 and a power of 10. So that digit has to be at least 1 and less than 10. So it can be 1 or greater, but it has to be less than 10. A couple rules, a couple policies to follow. When you're multiplying by a positive power of 10, it moves the decimal point to the right. If you're multiplying by a negative power of 10, it moves the decimal point to the left. And the number of places you move it, or the absolute value of the exponent, is the absolute value of the exponent. Do a little bit of practice here. We can see we've got a number that's times 10 to the 5th, times 10 to the 5th. So I'm going to move it the decimal point 5 places, and I'm going to be moving it to the right. So it's 9.62, 1 place, 2 place, 3 place, 4 place, 5 places. So it's 962,000 is that same number, that same value, only in standard notation. If we look at this number here at the bottom, it's 5.32 times 10 to the 4th. So it's 5.32, and I'm going to move it to the right 4 places because it's positive. 1 place, 2 place, 3, 4 places. So it's 53,200. Going on to the next examples, I wanted to show you one where we have a negative exponent for the 10. The negative 6 tells me I'm going to move it 6 units that way, 6 units to the left. So I've got 2.85. We move it 6 units, 1, 2, 3, 4, 5, 6. So it's 0.00000285 is that same number, that same value, only in standard notation. This one, kind of the same idea. It's to the negative 4, so it's 3.81, and I'm going to move it to the left because it's negative. So I'm going to move 1, 2, 3, 4. So it's 0.000381 is that same number, same value, only in standard notation. If we want to go from standard notation to scientific notation, here's the rules that let us do that. We move the decimal point to the right of the first non-zero digit. What we're saying is we move the decimal point whichever way we have to until we end up with a digit, a decimal point, and then maybe some more digits. But this digit must be somewhere between 1 and 9. That first digit must be somewhere between 1 and 9. Of course, you count the number of places that you move the decimal point, and that's the value. If the original number was between 0 and 1, the exponent is negative. If the original number was greater than 1, the exponent is positive. Well, let's practice. Here's our first number in standard notation. We want to write it in scientific notation, so I'm going to move 1, 2, 3, 4, 5, 6, 7, and 8. So I've got 9.315 times 10 to the 8th. The 8 is positive because I moved it. The original digit was higher. The original value was higher than 1. And of course, the number is still negative. All right. Down here, I'm going to move the decimal point 1, 2, 3, 4, 5, 6, 7. So I've got 3.56 times 10 to the 7th. And that's the same number, the same value, only in scientific notation. One of the biggest uses for this, we've got a couple practice here's yet. In this one, I'm going to move 1, 2, 3. I stopped right there because I had a digit that was somewhere between 1 and 9. So I've got 4.43 times 10 to the negative 1, 2, 3. This one, move it 1, 2, 3, 4. So I've got 6.53 times 10 to the negative 4. All of those numbers, I don't change the value when I do that. I just change the notation system. One of the biggest uses for this is when we've got very, very large numbers and we're trying to compare. So here we've got the radiuses of our planets in our solar system and we're trying to compare them. And we're in fact asked to put them in order from largest to smallest. So the way I do that is I cannot just compare the digits out front. I cannot just compare these digits. I have to look first at the power of 10 notation. So I'm going to look and find which one has the largest power of 10 notation. And you can see this one's 10 to the 4th, 10 to the 4th, 10 to the 4th, and 10 to the 4th. Since those are the largest powers, they're going to be my first 4 planets. Now I can look at the digits as long as they've got the same power of 10 notation. So I look at those digits right there. The largest digit is 7, so that's going to be my biggest planet. The next largest one is 6, so that's going to be my second planet. The next largest one, I've got 2.5 and I've got 2.4, so 2.5 is bigger. That's the third largest planet. This is the fourth largest planet. The next group I need to look at is the 10 to the thirds. There's a 10 to the third, there's a 10 to the third, there's a 10 to the third, and that's also a 10 to the third. Now I look at their digits. I look at their the digits out front. This starts with 6. This starts with 3. This starts with 2. This starts with 6. So I've got to look at the two 6s. 6.38, 6.05. So this becomes my 5th largest planet. This one becomes my 6th largest planet. This one, the next largest digit is 7, and this one is the 8th largest planet. Here's the same idea, but this time instead of dealing with radius, we're dealing with mass, or how big or how heavy the planet is. I've got to identify, again, the exponent, and I'm asked to identify them, to list them in order from largest to smallest. Largest to smallest, so I'm going to identify the largest exponent as I look down my list. 10 to the 24th seem to be the largest one, so that must be my biggest planet. That's number 1. The next set of digits I'm going to look at, or the next set of exponents I'm going to look at, would be the 10 to the 23rds. There's a 10 to the 23rd, there's a 10 to the 23rd. And that looks like that's all that I see is 10 to the 23rd. So that must become my second largest planet and my third largest planet. After 10 to the 23rd, I've got to look at 10 to the 24th, or 22nd. So there's only one of those. So that becomes my 4th largest planet. After that, I look at 10 to the 20th or 10 to the 21st. It's 10 to the 21st would be my next largest. So 10 to the 21st, pick out which one. Well, I've got 6 times that or 5 times that. So this must be my 5th largest planet and my 6th largest planet. The last ones are the 10 to the 20th ones. I can look at the digits there. They both have the same exponents. So I look at the 7 or the 3. This must be number 7 in order, and that must be number 8 in order.